So let's start the topic. What we have covered in earlier class. What is a power screw? It is a mechanical device which converts rotary motion into linear motion. There are some advantages and some disadvantages. Type of thread. There are most typically 4 type of thread: square thread, trapezoidal threads, acme threads, and buttress threads. Come to the point. What is terminology of the power screw? Pitch. First term is a pitch. The pitch is defined as the distance measured parallel to the axis of the screw. This is the axis. This is axis. This is axis. This is axis. The pitch is defined as the distance measured parallel to the axis of the screw from a point on thread to the corresponding point on the adjacent thread. This is a pitch. This axis and height of the pitch parallel to each other and adjacent threads. These are the adjacent threads. So second term is a lead. The lead is defined as distance measured parallel to the axis of the screw which the nut will advance in one revolution of the screw. When nut covers one revolution, means this length means complete revolution, then this distance is called lead. And come to the nominal dia is the largest dia of the screw. It is also called the major dia, and core dia is the smallest dia of the screw thread. It is also called the minor dia. There is one more term, helix angle. The helix angle is defined as the angle made by the helix of the thread with the plane perpendicular to the axis of the screw. Helix angle. The alpha is a helix angle, and if you open the threads of a ring, then structures will look like this. This is a lead, and this is a pi, and this is a dm. This is a diameter of the spring. So by geometry, as we know that tan alpha equals to length upon base by length by this length by this length. Torque. Come to the next point. Torque required to raise the load. Means how much torque required to raise the load. To draw this geometry and see the how much forces acting on this part of the body, and after by solving it we get the value of a torque required to raise the load, and same but how much torque required to lower the load. Means this example means as we know the function of a power screw is to convert rotary motion into linear motion. But if you load the system put on the power screw, then we have to remove that load. So this is the how much torque required to raise the load, and how torque required to lower the load. And come to the next condition. What is self-locking in a screw? When phi greater than equals to alpha, a positive torque is required to lower the load under the condition of the. Let's conclude the topic.